AI is now integrated into Chrome's security engineering pipeline. In today's presentation, see how Google, Microsoft, and others are using AI to semi-automate software fixes.
We're looking at a massive, fundamental shift in how software is built, and more importantly, how it's maintained. Now, if you follow the tech space, you already know AI is completely rewiring the industry. But today, we're diving into some brand new data and real-world pipelines from the big tech giants that prove this AI revolution is moving in a direction literally almost no one predicted.
So here's the question for you. Think about the last 3 years. Literally all the hype has been totally obsessed with AI coding assistants, right? We've been talking nonstop about GitHub Copilot, ChatGPT, Claude Code, the Gemini CLI, the whole shebang. We've been completely fixated on this idea that AI is just going to write all our new apps from scratch. But what if that's actually just a sideshow? What if the absolute true superpower of AI isn't generating new code at all, but untangling and fixing the millions of lines of code we already have running in production right now?
Okay, let's dive right into this paradigm shift we're witnessing. First, we have the old view, right? AI as a productivity aid. This is your classic chatbot setup. You ask it to write a function, it spits out the function, and you move on. But then we have the new reality, AI as an engineering system. We're talking about fully integrated autonomous pipelines, where AI doesn't just, assist a human developer. It's continuously monitoring, discovering, triaging, and patching software basically on its own. It's a massive leap from a helpful little assistant to an entirely automated maintenance crew. Section 1, the disruption, Google Chrome. Let's look at the absolute clearest public example of this shift operating at production scale. I really want you to let this number sink in for a second. 1,072. In just 2 recent versions of Chrome, versions 149 and 150, Google's security team fixed 1,072 security vulnerabilities. And they did this by heavily integrating their new AI-assisted vulnerability management pipeline. Now, obviously that number alone is absolutely huge, but we really need some context to understand just how crazy this is. Now, what's really interesting about this is when we compare it to the past, 1,036. That is the total number of security fixes from the previous 23 Chrome milestones combined. Let that just wash over you for a second. By using their AI pipeline, Google patched more vulnerabilities in just 2 updates than they did in the previous 23 updates put together. That is a completely unprecedented leap. Now, I know exactly what some of you might be thinking. You're thinking, wait, did AI suddenly write a mountain of garbage spaghetti code that caused all these bugs? No, absolutely not. The bugs were already there. They've been hiding in the codebase for years. Google didn't just magically make Chrome less buggy overnight. What actually changed is that AI dramatically increased the rate at which these hidden, lurking vulnerabilities could be hunted down, validated, and just dragged out into the light. It really proves this long-standing engineering truth, Finding defects is actually a way better target for automation than designing entirely new systems from scratch. Moving on to Section 2, the breakdown. Google's AI pipeline. So how exactly are they pulling this off? Because it isn't just one magical chatbot solving everything. It's a highly, highly engineered system. Let's actually walk through this workflow step by step. Google is using large language models across basically every stage of the lifecycle now. First, discovering the vulnerabilities, then actively reproducing those reported bugs just to prove they're actually real. Step 3 is determining how severe they are and routing them to the correct team. And Step 4 is where it gets really wild, generating the actual candidate patches to fix the bug. Then, creating regression tests to make absolutely sure the fix doesn't accidentally break something else. And finally, Step 6, human review. The AI is literally doing all the heavy repetitive lifting, handing this perfectly wrapped package over to an engineer who just has to review it, approve it, and ship it. Now, let's look at how this evolved, because this definitely didn't just happen overnight. Google has been laying the groundwork for this for years. They started out with AI-assisted fuzzing. Then we saw Project Zero's naptime research, which was looking into AI for vulnerability discovery. And that evolved into Big Sleep, which was this project where AI actually identified previously unknown zero-day software vulnerabilities. And now, all of these isolated, individual experiments have converged into the single, unified workflow we're seeing today. Which brings us to Section 3, the new engineering bottleneck. Because as you can imagine, automating this much of the pipeline creates a really fascinating, kind of counterintuitive new problem. The bottleneck is no longer discovery, it's engineering review. Historically, right, the hardest part for any security team was just finding the bugs in the first place. You never, ever had enough human eyes looking at the code. But today,
The AI is finding these vulnerabilities way faster than human engineers can comfortably review, validate, and ship the patches. The AI is essentially burying the humans in paperwork. Actually, scratch that, it's more like a tidal wave of fixes. The humans are now the slow part of the system. And this is exactly why Google is being forced to move Chrome toward much more frequent dynamic updates. They literally have to do it just to clear the massive backlog of fixes the AI keeps handing them.
All right, Section 4, Microsoft's parallel strategy. Because this completely proves we're looking at a massive industry-wide evolution here, not just some isolated Google outlier.
And this brilliantly illustrates the sheer scale of what's happening out there. Microsoft has introduced M-Dash, the multimodal agentic scanning harness. And this isn't just one single AI. It is an entire platform coordinating over 100 specialized AI agents that are specifically designed to discover vulnerabilities across Windows. And we aren't just talking about simple web bugs here, guys. M-Dash is finding critical remote code execution bugs in notoriously complex, highly secure areas of the operating system. I'm talking kernel mode drivers, TCP/IP-SDOS, HTTP.SDOS. These are areas that are incredibly difficult for humans to audit manually. But there is a super fascinating difference in how these two giants actually approach the finish line. Google's pipeline is incredibly aggressive when it comes to having the AI actually write the patches and the regression tests. Microsoft, at least publicly, is playing it a bit more conservative. Their messaging really emphasizes AI for discovery, validation, and risk prioritization. When it comes to actually fixing the code, Microsoft heavily utilizes GitHub Copilot autofix for sure. But they are very clear that humans are in the driver's seat, heavily leading that remediation and integration process. So what about everyone else? Well, Meta has discussed using internal AI for code reviews and static analysis. Amazon has obviously invested heavily in developer tooling with Amazon Q. But the rest of the industry, honestly, they are still mostly talking about AI as a simple coding assistant. Continuously discovering, triaging, and repairing production software at this kind of scale is a total elite game right now. And publicly, Google and Microsoft are the ones leading the charge and setting the new gold standard. So, the crucial point is Section 5, the agentic software future. What does all of this actually mean for the human software engineer? Well, if you work in tech, this shifting dynamic is your future. The engineer's role isn't disappearing, it's just shifting up the ladder. AI systems are going to take over all those grueling, repetitive maintenance tasks. They'll discover and reproduce the bugs, localize the faults, propose the repairs, generate the tests, the whole 9 yards. But human engineers, you're going to be elevated. You'll lead the overarching architecture and design. You'll conduct the high-level code reviews. And ultimately, you will be the one approving the release ships. It's like you're moving from being the line mechanic to being the chief engineer. Which leaves us with this final, really profound question to consider today. If the first massive, large-scale impact of AI in software isn't actually writing new features, but maintaining the millions of lines of code that already exist out there, then in a few years, who will really be maintaining your software? The next generation of technology won't just be built with AI, it will be maintained by it. Thank you so much for joining me on this explainer, and I highly encourage you to go look deeper into your own tech stacks and see exactly where this pipeline revolution is already beginning to take hold.